to get that 100% vented to the outside. That's really expensive. Like in my hospital, the main hospital, if I were to do that, the estimate that I got was $275,000, because I would have to put a huge blower in and have to take it up 7 stories to the roof. So that's a big expense just to vent that hood to the outside. They also say that obviously those should be situated in the ISO 7 negative pressure area. In terms of containment, there's been a lot of interest in closed system drug transfer devices. There's a great study out of MD Anderson by Susan Spivey where they used fluorescein dye as a surrogate marker for chemotherapy. And they did a whole number of manipulations using needle and syringes, and then they photographed the results under UV light. And there wasn't one single instance where they didn't have evidence of contamination using traditional negative pressure techniques with needle and syringe. They repeated those manipulations using closed system transfer devices and saw no evidence of contamination. So pretty interesting there. I think that the one big thing as practitioners we should look at when we're thinking of these devices is the device truly a closed system? Right now, I think there's only one device on the market that actually keeps the system closed from the pharmacy to administration to the patient, and that's the Facile system. There's a lot of new systems that are coming out, but at various points in the system, it's actually open. And usually where it's open is in the pharmacy. And many of them use like a dispensing pin with a filter needle or with a filter on it. And that will trap aerosols, but what it doesn't trap is gas. And there's actually multiple studies, some from Germany and some from the United States, that have actually demonstrated that at least 7 drugs that we compound and handle on a routine basis actually form volatile gas at normal conditions of room temperature and pressure. So when you vent that vial, what's actually coming out of it is active drug. So even if you're wearing a mask, it's going to go through the mask and you're going to breathe in and absorb active drug into your system. And it's pretty interesting for us in Utah. You know, the hospital is actually about 4,800 feet above sea level. So when we get drugs that are packaged at sea level and then they come up 4,800 feet, that pressure gradient is significantly magnified. So like the big platinol vials, when we get those, we can stick a 60 cc syringe in there and you can watch the plunger get pushed out because of the pressure. So that's really magnified for us. And you know, before we actually started using the closed system drug transfer, you know, we would vent those, and you could actually hear an audible whoosh of air coming out of those vials, which contained active drug, which we weren't aware of initially. But we've since changed that. The other interesting thing is, you know, you may even be working in the biological safety cabinet, and a lot of people feel that working in the biological safety cabinet, I'm safe, right? That's the name, biological safety cabinet. You're not really. It's important to remember that those cabinets are designed with nothing in them. When you start putting things in your hood and disturbing how the airflow patterns work in the hood, you have the potential for what's in there to actually get out. And there's a really interesting video where they show a technician that has the hood all loaded up, ready to work, and they fill the hood up with smoke. And then as she sits down to work in the hood, you can watch her put her arms in, and you can watch the smoke migrate right up her arms into her face. So, you know, it's important to remember that, you know, that actually can create a bit of a false sense of security, that as you disturb the airflow, or if you cover up those vents with your arms, what's in there can come out. So closed systems, NIOSH certainly recommends closed systems in about 6 different places. And at the University of Utah, we had the opportunity to do some of the initial testing for the studies that were included in the NIOSH alert. And what we did was, you know, I was pretty interested. About 7 years ago, I actually went to a presentation on the Facile system, and I'd never heard of it before, and I thought, well, that's kind of interesting, but I don't know if I want to invest in that. I don't think I have a problem, because I have a brand new cancer center that I just built. It's got the best equipment, everything is vented. I have my best technicians over there, my best pharmacists over there. I thought, all right, I'll see what I have. So we actually did, 3 months after we opened, we did surface wipes, and we looked at 17 different locations. We looked at the hoods, we looked in the clean room, we looked in the ante room, we looked in the medication room, we looked at the nurses' stations, and we looked at the patient chairs. And I thought we'd be clean. We were positive for contamination in 17 out of 17 locations in a brand new facility after only being open for 3 months. So I thought, okay, well, what's on board then? So we got all of our full-time technicians, pharmacists, and nurses, and we did 24-hour urine collections on them. And we did that on a Friday, when theoretically they should be at their highest exposure rate. So that was actually kind of fun, because they all had to carry these little jars around all day and be like, I know where you're going. But, and then we tested we had them record the time and the volume of each void, and then we tested each void for cyclophosphamide and ifosfamide. And we actually had the luxury of doing that because as part of the 2002 Winter Olympics, we got some really cool mass spec and HPLC equipment to do the drug testing for the Olympics. So as long as we had that, we thought, let's use it for this. And it was really astounding what we found. 100% of the nurses were contaminated, 100% of the pharmacists were contaminated, and 30% of the technicians were contaminated. And it was really kind of interesting with the technicians, because the way I staff my technicians, they're only in there one day at a time. So in the infusion center, we have one technician mixing, one technician doing the retail prescriptions, and one technician assigned to investigational studies. So that person doesn't really mix at all. So I thought I might have the person mixing contaminated, but the other two should be fine. And what I saw was the person doing the investigational studies was off the charts in terms of contamination compared to everybody else. And she was the person that wasn't mixing at all. And so we were scratching our heads. We reran the tests thinking maybe we messed the samples up, and it came out the same the second time as well. So we went back and looked at what that person was doing on a daily basis, and it turned out that was the person that was actually unpacking the drug order when it came from the wholesaler. And so we thought, So we tested the vials and the totes that were coming from the wholesalers, and lo and behold, all of the cyclophosphamide vials were contaminated, significantly contaminated, and one of them actually had like 8,800 nanograms on the outside of the vial. And so, we reported that to NIOSH, and that was actually one of the genesis for the study that NIOSH did on vial contamination that they just published last year in AJHP. So we actually immediately changed our processes so that when those things come in, we wipe them down now with hypochlorite solution, and everybody wears personal protective equipment when they're unpacking the drug order. And so we actually repeated that study then 6 months later, and after we'd implemented the Facile system, tested the same 17 locations, and we did urine samples on the same nurses, pharmacists, and technicians. And what we found was we still had some contamination, but it was significantly lower. And that's consistent with what everybody else has published as well. But the really exciting thing for us was that none of our techs, pharmacists, or nurses had any measurable drug on board. And the first time through, what we saw was it was kind of a big pulse. The techs and the pharmacists and the nurses would come in and they'd be clean. And then during the workday, you'd see the contamination start to rise, and then it'd peak, about 6, 7 o'clock at night after they went home, and then it would go down. And so, the big question for us is cyclophosphamide is an IARC group 1 carcinogen. Given enough exposure, you will get cancer from that agent. There's about 90 substances that fall into that IARC group 1 classification, and 12 of those are drugs. So for us, we're asking the question, well, if we have routine intermittent exposure to a known carcinogen, how much is enough? And nobody knows that, but personally, those are my friends and my colleagues in there. And for me as the director, I'm responsible for them, so I said 0. So we're going to do everything we can do to make sure that they don't have any contamination on board. So we've actually implemented that system throughout the house. And it does have a cost to it, because it is a disposable. So there's a lot of places that are still struggling with, well, is that cost worth the investment? And for us, we didn't even look at it as a cost issue. We looked at it as a complete safety and quality issue. So we just went ahead and did it everywhere at the University of Utah. USP in the current iteration actually talks about closed systems. They've adopted some of the NIOSH standards. So what they've said is that if you're going to use a closed system transfer device, make sure you use it in a biological safety cabinet or a compounding aseptic isolator. I think you see a lot of use out there now, particularly in places like veterinary hospitals or clinics that do chemotherapy but really can't afford a clean room. As an alternative, they're using closed system transfer devices outside. And I guess that's better than what they were doing, because my own vet was mixing on the picnic table outside the facility to avoid internal contamination, but not exactly ideal for operator safety. They're also talking about this as an alternative for smaller places. if you're doing low volume chemotherapy, like some of the rural hospitals, you know, might do 4 or 5